Hi everyone, welcome back to Workshop. It's been a while since I've done any kind of repair video or refurbishment video on any test equipment, so I've managed to pick up this Solartron 7075 digital voltmeter on eBay. It's a 7.5 digit multimeter, and I think this particular one dates back to about the mid-80s. So Solartron as a company actually dates back to the 40s. In 1947, a couple of engineers in the UK started making some test equipment, some oscilloscopes, power supplies, pulse generators, that sort of thing. And in the 1950s, that's when the company started to grow and expand their equipment range into other areas like X-ray spectrometers and that sort of thing. And it was 1962 that the Solartron Electronic Group was acquired by the Schlumberger Group, and this meter I think comes from that era there afterwards. The Solartron Electronic Group, it actually says in the back of the device that it was made by that company. So this particular multimeter that I've got here I think dates to about the mid-80s, according to the time stamp on the date stamp on some of the ICs inside the unit. Other than that, I don't know a hell of a lot about Solartron and well, especially the 7075 digital voltmeter. It's all pretty new to me. So like I said, I picked this up on eBay. They can be had real dirt cheap on eBay. It's amazing the price they go for. I think the cheapest I've heard of is 28 UK pounds for a working model. You know, given the complexity inside, that really is quite cheap. How good they are as a 7.5 digit voltmeter, for instance, yet to see, but that'll come out in the wash as I make this refurbishment. So like I said, bought this on eBay, wasn't packed very well by the seller and did sustain some damage. I'll just grab a couple of brackets here. There is actually supposed to be a couple of brackets that go on the end here, and they were fitted at the time of shipping. However, the whole unit was face down in its box, and the handles are basically just bouncing off of the ground every time the box is moved around. So as such, the actual handles had shattered there, but luckily the fascia and the push buttons in the front there are totally intact. There's no damage at all there. So one of the things that I'm going to be doing as part of the refurbishment is replacing those handles. So just a little close up here of one of the handles, which is intact. That's how they sit there. However, you know, you can't get these on eBay or anywhere else that I can see, so I decided to make my own. So I've actually gone and laser cut acrylic, 6mm I think that is. I mean, it's not going to be that strong. It's certainly not going to be as strong as the original, which is significantly thicker and probably of a stronger material. However, I think the acrylic ones are just going to make it look a bit more pleasing on the eye there, and it'll look better on the workbench. So the idea is to get this unit up and running, repair it as necessary, make some modifications to it, and calibrate it and get it on the workbench. It's just another meter for me to use in the workshop. So let's power her up and have a look. Does actually power up. It does actually seem to work in its basic form. At the moment I've got it on DC input there, and I've got the integrator set to 1 second, so that means the display is going to update roughly once a second there as it averages a whole load of results. So you can see I've got 10 volts actually set on my own precision voltage source there. And okay, I've just powered it up, so it's going to take a while to settle. It is actually still climbing there. It never actually reaches 10 volts, it's actually a little bit less, maybe as much as a few hundred millivolts less, so I think it does need calibrated. However, one of the main things that I do want to do to this unit, other than calibrate it, etc., is down here on the right hand side is the input connector. It's rather proprietary. It's a 5-pin connector, but it's not like a DIN connector. It's got weird spacing, and I don't have the mating connector for here, and I'd rather not use one, to tell you the truth. It's just another tail coming off, breaking it out to bananas or whatever, and then using it to hook up. So I'd rather not do that. So what I do plan on doing is replacing that connector with 5 banana sockets which I've got here to replace the 5 pins. I think there's enough room there that I can make a small panel and basically line up the 5 banana sockets there. I probably need to move that microvolt offset button. I'm not even really sure what that is at this moment in time. I think it's just a 0 basically for the low end of the voltage scale. I'll probably move that maybe around the side or up on the top, somewhere like that, somewhere accessible, and it'll give me that real estate there. Hopefully, once we have a look inside, I've got you know, there's nothing in the way there if I'm putting these bananas through to that, but we'll see that when we open it up. So it's been powered up now for about 10 minutes, and you know, it's less than a millivolt out on the voltage scale there. The integrator here is set at 1 second, so I'm not getting the 7.5 digits yet. If I just go over to 10 seconds and I get an extra digit, and it'll update the display after about 10 seconds once it takes an average. There we go, so I've got the extra digit on the end there, and it'll be another 10 seconds before it updates again. So there's a little bit of recalibration required. So I think the first thing to do is get the covers off, have a look at behind the input connector there, and let's see if I can find space for my banana sockets. Okay, so there's a couple of screws in the back there what I've already undone, so we'll slide the cover off and it just lifts off, and we can have a look inside. So here we are inside. It's really clean. There's virtually no dust whatsoever, and I think the reason for that, the unit doesn't actually have a fan anywhere, so it's not sucking any air in from the outside along with all the dust. And looks like the unit's built on some sort of I don't know if that's some sort of plastic chassis there, other than the metal, but surrounding it there's like a plastic chassis, and then you've got like more or less 3 separate compartments: the power supply section at the back, and then I presume a double stacked board in the middle here. That's probably going to be the processor and the main processing, and then the front here looks like you've got some sort of the electronics for driving the display, that sort of thing there. But like I said, I don't know too much about the unit at this moment in time, but we'll probably get better into that, deeper into that as we go along. So let's take a look at that input connector. So here's a corner here with the input connector on the front. You can't actually see that much. You've got a vertical display board there, and of course the horizontally mounted boards at the back there. You can't actually see much at all. So I think what I'll do is I'll start disassembling this front chassis part here, the display panel here, and see if we can get better access to the connector at the back there. The top bracket there has come away now, and looks like I can lift out the display bezel there, and yes, it looks like we've got better access to the connector. Let's have a look. So there's in behind that front panel connector there, you can see it just there, and then alongside that is this microvolt offset adjustment pot there. Looks like there's no PCB that'll get in my way. There's this PCB here, but it doesn't come down as far as that input connector, so it looks like I can get underneath that board at the front there with my banana sockets. So let's dig a bit deeper and see if we can get better access. Well, these screws are actually marked, so it's definitely been disassembled at some point in its life. That top bracket off. And the circuit board looks like it can just lift out. There's a connector in the middle there. Yes. Ah, yes. Got much better access now. Let's take a look. Yep, and so there's the connector there and the pot, and nicely cut away from there on that bottom PCB is a nice area there that looks like I can reuse for the back of the banana sockets. Now, what I will need to do obviously is take off this panel here, but I'm not just going to go and drill random holes on the front here for my banana sockets. I want it to look pretty good from the front, so I'm actually going to laser cut an acrylic front panel that will just cover those old holes and the old text in the front panel there, and that'll lay out my 5 banana sockets there. So obviously I'll be doing away with that input connector there. Hopefully those tails on the back of the connector there are long enough, or I can pull them through to mate up with the back of the banana sockets here. But this offset, microvolt offset pot, I'm going to have to reposition. So it looks like I might be able to just rotate that round 90 degrees and maybe drill a hole on the side of the panel here that pot can then get access to. I don't think it's something you need to adjust all the time. I think it's just for adjusting zero every now and then, I would reckon. So having it on the side rather than the front, I don't think that's any great deal. It's not like I'm going to be rack mounting this multimeter in a in a 19-inch rack case or anything like that. So I think that's what I'll do. I'll take some notes on the wiring of this connector and then disassemble it all and start marking out my holes, etc., for the new front panel in the corner here. First things first though, I will have to remove this front panel here. One other thing I'll have to be wary of is this display board here is not on a connector. Well, it is on a connector here for mating up with the bottom board, but I've got 2 tails here, 180 volts and minus 18 volts supply here. I'll desolder that if I have to, because looks like they were meant to be removable, but somebody soldered them on. So I'll probably just leave that in place at the moment and just position that there out of the way there. So that it can give me access to work on this front panel here. But like I said, I'm going to have to remove this, and it looks like there's a couple of screws on the bottom and from the underside, similar to what was on the top, for this bracket along the bottom here that's holding it in place. So I'll just loosen those screws on the underside, and that should free this front panel so that I can remove it. Okay, that's that bottom bracket removed. So now this front panel should just come out, and there it goes, and that'll give me good access to re-drill the holes. Quite thick aluminium plate, that looks to be about 2mm or something like that there. So like I said, here it is. I'll just put an acrylic panel, probably black, 1mm or something like that, so it sits nicely into this corner here, and then I can print some new labels for the identification of the new banana sockets there. And also I'll probably give us a clean up. These small bezels for the push buttons there, they've kind of sort of like yellowed in age. I don't know if you can pick that up in the camera. So it looks like they just unclip there and they'll come out the front, and I'll probably drop them into something and see if I can give them a clean up. What I've also gone ahead and done is laser cut my little acrylic panel there using 1mm acrylic there, and I mounted the banana sockets on that. These 4 here are 19mm apart, so they conform to the standard 19mm spacing between bananas, and this guard socket here I've just sort of mounted where I could. It's not in any real spacing, but what I needed to do was cut a mirror image acrylic on some slightly thicker material to go in the back. The reason for that is there's a great big hole where the original connector was, and of course that was right smack almost where this guard socket was. So to get round that, I cut another bit of mirror acrylic, mounted it on the back, and that makes it pretty firm there. Then it means I can mount those banana sockets anywhere I liked. So I've just got to push this together here and get it nice and secure, and I've put back on the strip along the top here, which is held on by a couple of screws there, and it's basically ready for soldering up to the wires here and some reassembly. Alright, that's it all back together again. A little bit of a schoolboy error. I'd forgotten that the second PCB is a bit deeper, so I had to actually move the offset pot, and luckily there was a fixing screw there, so I've just extended that with a plastic standoff so that I can mount it without electrically connecting the pot body with that trace at the bottom there. Although that's ground, because this is a precision instrument, I want to keep any ground loops to a minimum, or zero in fact, so I've used a plastic standoff there to mount it, so it's secure enough, and it's just below the height of the top panel, so that when I drill a hole in the top panel, the pot will be readily accessible from there. As far as the rest of it went, no problems at all. I'll just bring you around the front, and that's all in place there. It's not fixed on yet properly, but that's basically what it'll look like there. I just need to glue that end of that there. It's curled round a little bit, but hopefully the end plate will be able to hold that in place, no problem there. So I think it looks okay, no problems at all. The idea to get the perspex at the back's held it on pretty firmly. The guard banana socket there is secure enough, no problem at all. Okay, couldn't resist it. I've gone actually ahead and fitted the handles on the end there just to see how they mate up, and it looks not too bad. I've also gone ahead and the little bezels round each one of the push buttons, I just gave them a very, very quick light rub with acetone, which actually, you know, will actually melt that plastic, but if you're very, very quick and careful, you can use that to get rid of the yellow on the actual plastic, and it's done that, and it's come up not too bad. I've got two of them at the end here which are actually broken, so I've got them sitting elsewhere and gluing. And the only other tiny little minor thing that I've gone ahead and done, the actual on-off switch, I don't know if you noticed previous, it's got a little legend engraved on the top, black painted in the top, a little squiggle, a little bit like that one there, which signifies where you know, it's on or off. I just thought it looked really untidy, so I just rotated the red knob there, and it looks, I think it looks a lot cleaner there. The only other thing I've got to do is a little bit of clean up in the metal work there, but I did actually clean the front panel, and it's not looking too bad there. And a little bit of a zoom in on the bananas there, and it doesn't look too bad. The only downside I've got with these handles that I've put on is they don't have the little channel on the inside which helps hold the middle part of the split on the front panel there in place. So, you know, it does kind of tends to move a little bit there, so it's not too bad. It'll be alright on the workbench, but I wouldn't like to be moving the multimeter around too much with it like that. You know, it's just will move a little bit out and in a little bit by a mil or so. Actually, I just had another idea there. I've gone and changed the design slightly of the end handles there in order to try and keep this panel in that way. I've made another piece of acrylic here which I've bolted to the inside side of the handle, which sits in front actually of this centre bar here and has the effect of holding it in place. I've designed it so it's nice and tight up against that horizontal there, and it actually holds it in place. And if I move over to the other one that I haven't actually done yet, you'll see what I mean. It's going to hold that in place there. So I'm just away to get the other side done here. It's actually cutting in the laser cutter right now, and then I'll bolt it up. There's one other little bit of hardware that I need to look at. I'll just switch it off at the moment there, and that is this capacitor at the back here. It's got this little bracket to hold it in place, but as you can see, it's not doing too good a job on that there, so I think I need to remove that bracket, put a little bit of neoprene gasket under there, a thicker piece, and it should help hold that in place. Okay, we're ready to take a look at calibration now. I'm not going to go through the entire calibration procedure. The manual, it's quite lengthy in terms of pages to trawl through. I'm just jumping straight in, and I'm going to take a look at the 10 volt range, the minus 10 volt to plus 10 volt. So here's the unit here, and the calibration is done on the board that sits underneath this one here. There's a whole bunch of potentiometers on the board, but what they have done, they've put holes in the board. I'll just zoom in a little so you can see, and marked them very clearly about which pot's what, and that ties up nicely with the calibration manual. So the idea is I'll dial up at, for instance, 10 volts on the precision digital voltage source. That'll record a value down on the 3458a. As you can see there, it's already reading a value of 10.000062 volts. So therefore, I'll be replicating that on the display of the 7075 when I get into calibration. Well, I've calibrated as best I can. Looks like you need to do more with the GPIB than what I originally thought about commanding the different voltage ranges. So it looks like I can only calibrate the 10 volt range. It kind of looks like a default range for the unit. But like I said, I don't know too much about this unit at the moment. I'm just sort of winging it a little bit. But you know, if I can get one of the ranges calibrated, that'll be fine. And it looks like I've gone and managed that on the 10 volt range. So I've got my voltage source, I've dialed up 10 volts, and as you can see here, I hope you can read that, 10.000058, and up on the 7075, 10.000065 or 6 here. So that looks not too bad at all. And I'll try some other ranges in the middle there. So I'll try 5 volts. Other values in the middle there. Take a second for the 3458 to come in because I've got quite a high NPLC. There we go, 4.59s and an 8, and there we are on the 7075. I've got basically the same thing there again. Okay, I've just dialed up 2.34567 volts, so you can see in the 3458 2.34563, and correspondingly on the 7075 2.345623, so it is pretty damn close. So there we go, that's all I'm going to do to the unit at the moment. I'll probably revisit calibration later on, but that's good enough for the moment. I can box her up and put her on the test equipment shelf. And just a quick look here before I do that. I've labelled up the banana sockets in the front there. And I've also gone ahead and secured this capacitor here with a new bit of neoprene gasket under there, and I've bent the bracket slightly so it's got a much sturdier fix on that capacitor there. So there's the 7075 in place in the workshop. Decided to put it just above the 3458A, and all done and dusted. Thanks for watching.